very first problem here, because this is going to be kind of similar to what you're going to see in the other problems we're going to create today. So I've just got a little review question. We got 4, and then in parentheses I have x plus 3 squared minus 12 equals 388. So if I want to solve this equation, what would you do first? What do you want to do first? Let's add 12. Good. Get rid of any addition or subtraction. It's kind of like order of operations, and it is order of operations in reverse. All right, so that's going to give me 4 times the little parentheses, x plus 3 squared equals 400. Okay, what next?
Divide the 4.
Yes, do not distribute. You want to divide. So just, ooh, I'm breaking my pencil. All right, divide by 4. And I'm going to come write this over here so I have a little bit more room. So I still have the parentheses, x plus 3 squared. 400 divided by 4 will give us 100. Okay, what next? Square root. Don't FOIL. You want this. You want these parentheses. This is what we want because you can just get rid of them by taking the square root. What's the square root of 100? 10. Perfect. Okay, that's what I was going to ask you. You got to put that plus or minus symbol in front of the 10 because it could be 10 or negative 10 if we introduce the square root. Okay, now this kind of has 2 more steps. So I need to move the 3 away from the x. So I'm going to subtract that real quick. And I would just tell you, just write that negative 3 just right after the equal sign and just kind of scooch the plus or minus 10 over. All right. Now, if that is plus or minus a number, like it's just 10, it doesn't have a radical, doesn't have an I, then you can take this a step farther and actually add and subtract that 10 from that negative 3. So I'm just kind of thinking about like kind of going across the top. If I do negative 3 plus 10, I would get 7. And if I do negative 3 minus 10, then we get negative 13. And you're going to see, that'll be the same kind of a concept you'll see on some of the questions today. Some of them you might just, at that step, you might be done. Like I said, if it has a radical or if it has an I, when you take the square root, then you'll just have that just to move the number away from the x. Otherwise, if it's a plain number, like that was just positive or negative 10, you can actually combine those with the negative 3. Okay, now, this is hopefully going to be a review. But I've got my quadratic in standard form here. This is not an equation, but it just says standard form ax squared plus bx plus c. I'm going to see if you remember the little factoring that we did. So we did multiply a times c. This is going to be easy today because all the a values are going to be 1. And add to get the b value to help me factor this. So I'm going to just do my 2 little sets of parentheses. And for both of these questions, it's just going to start with an x. And these are perfect square trinomials. If you don't remember what that means, that's why we're going to review it here real quick. But you're going to get this perfect square trinomial, or we're going to create one in every single one of the questions today. So that's why I wanted to review it. So the one on the left side is x squared plus 10x plus 25. So to fill in my factors here, I would need 2 numbers that when I multiplied them, I got 25. When I added them, I would get 10. Can we? 5. Okay, so that's what it means to be a perfect square trinomial. Both of the factors are the same. Can anybody raise your hand and tell me another way I could write that? Not for this one. What do you think? Yeah, that's what I was trying to get. If they're exactly the same, the entire thing can be squished together. And you can write it like this, x plus 5 squared. Now, I'm just going to scooch this down just for 1 second. So, did you guys see in this question, like in the equation, we ended up with a set of parentheses squared, and then we just got rid of it by taking the square root? That's what we're going to try to create in these equations today that we're going to solve on the back. So they look like this. So we're going to create a perfect square trinomial. So let me try one more. For this other one, can you think of 2 numbers when you multiply them, you get positive 49, but you add them, you get negative 14? 7. Yes, they're both negative 7. All right, and so if they're identical, that is the little thing that allows us to write it as just that one set of parentheses, and it's squared because you have 2 of them. And that's going to be the entire purpose of this. Okay, now there's a tiny little formula today to make this happen if you don't already have it in an equation, and so that's what's right underneath here. So the number on the end, which is your plain number, the letter C, is the constant term. And I do want to make like just a tiny little, you're not going to see any questions that don't have this today. We're going to deal with this tomorrow. But the a value, so in front of your x squared, it just has to start with x squared. You can't have like 2x squared or 5x squared, or you can't even have negative 1x squared. You just have to start with x squared. Okay, now, if this is a perfect square trinomial, then the number on the end, the number on the middle can be anything that has to start with the x squared, but the number on the end that doesn't have an x with it, c value, that's your constant term, has to be the b value divided by 2 squared. I call that the magic number, all right? If that's the case, then what you have in front of you will be something where the two factors are exactly the same. So it's just the b value divided by 2 squared. So all we're going to do in this example at the bottom here is just practice making a perfect square trinomial with the information that we have. So I just need, like what I have here, I've just got x squared plus 20x plus blank. Now, the reason this is a plus on every single one of these is because when you make this number, you're squaring something. And whenever you square something, it's going to make it positive. So that's why I have a little blank. We're going to fill this in real quick. So I just need the b value. B value is the number that is in front of x. So like for this question, it would be 20. All you're going to do is you're going to take 20, we're going to divide that by 2 and square it. So this would be 10 squared, which would be what? 100. Okay, now 100 is the number I would fill in that little blank with. Tell me two numbers that multiply to give you 100 where they add to get you 20. 10 and 10. Okay, now here's what I want you to notice. So this would be x plus 10 times x plus 10, or the entire purpose of doing this is so we can write it as x plus 10 squared. I'm going to write that at the bottom of the page. What I want to draw your attention to, okay, I swear to you, if you do this correctly, whatever you square, like I squared 10, that should match the number in the little parentheses with the x. Whatever you squared, that should be the number in the factor with the x. So if you have trouble coming up with it. All right, let me try another one here. So this one, my b value, right, is just negative 8. So to get this number, it's the b value, which is negative 8, divided by 2 squared. All right, so this would be negative 4 squared. What do I get if I square negative 4? Positive 16. No matter what you plug in, you're going to square it, so it should always be adding something. So in this case, it'd be 16. Okay, now, I swear to you, I promise. Whatever you square, right, multiply to get positive 16, add to get negative 8. This would be x minus 4 times x minus 4, or the entire purpose of doing this, so we can squish them together and write it as x minus 4 squared. But note, like I squared a negative number, so then in the little parentheses, it's x minus that number. I promise if you do this correctly, and you're going to be like, why are you harping on this? I could have figured this out. This is the reason I'm harping on this right here is this last question. Okay, now in this problem, the b value is not an even number like it was here. So like here, I could divide negative 8 by 2. Here, I can divide 20 by 2. Here, it's the b value, which is negative 3, divided by 2 squared. Okay, now, I can't actually simplify that, right? It's just negative 3 over 2. All right, but I can't square it. The way this would work, you literally square the top and you square the bottom. Just do it as a fraction. So negative 3 squared would become positive 9, and 2 squared would become 4. So that's the number that would have to get added in here to make this. Okay, now, I know this is a little bit weird. Don't change it to a decimal, just leave it as a fraction. Now, remember what I just told you. I swear, whatever you squared, that's your factor. Well, what I squared was this, negative 3 over 2. And so the factored form of this would be x minus 3 over 2 times x minus 3 over 2. And just leave that fraction in there. That'll make a little bit more sense when we do a problem on the back. But you want to leave that as a fraction. I'm not going to ask you to FOIL that out, but if you did, if you wanted to try that, it should give you what I have right above there. So it can be very tricky if your b value is odd. You're going to have to work with a fraction. Most of the questions are going to be even numbers, so you won't have to worry about that, but just in case. Okay, now, I'm not going to read this to you, but you can if you want to. The completing the square, this is just all the steps, and I'm going to walk you through it, and it's probably a lot more, it's a lot quicker than what I have written there. But that goes through the entire process. The one thing is, like I said, you're not going to run into this today, but in this question, it says the A value must be equal to 1. If it's not, we're going to deal with that tomorrow, but you're not going to see that on any problem today. That shouldn't be an issue. Okay, what you want is you want any plain numbers. I already have these all set up like this for you, so you shouldn't have to move anything, but you want the two terms that have the x squared and the x, the quadratic term, linear term, you want that on one side. Any other numbers that are in the problem, like a plain number, you want that on the other side. Okay, here's how I'm going to set this up. So I'm going to kind of do like what I did on the last example, but now I have an equation. So I'm going to write x squared plus 8x, and I'm just going to put plus because I know I'm going to square something to complete the square here, and I'm just going to put a little blank just like the last example. The difference here is this is an equation, so when I add this number to complete the square, I have to do it on both sides to keep my equation balanced. So I just recommend, I literally tell people just put plus a little blank on both sides so you don't forget to keep your equation balanced. Okay, now this is that same little b value, right? B value here is 8 divided by 2 squared. So this is going to be 4 squared, and that's going to be 16. Now that's the number I'm going to add. On the left side, it's going to give me a perfect square trinomial. On the right side, I got to do that just to keep my equation balanced. So I decided to add 16. I got to do that to both sides. Now, whatever you squared, I promise, if you can't think of it, that's going to be your factor. So the factored form, multiply to get 16, add to get 8, would be x plus 4 times x plus 4. The other side's just 20 plus 16, so this is 36. Now, the entire purpose of doing this, adding this 16, is that these two factors should be identical, and so we can just write it as x plus 4 squared. If you understand that and you want to just go right to that step, that's totally fine with me. Is that what you're going to ask? Yeah, you don't have to write this out, okay? If you're just like, okay, Ms. Grody, I know this is going to be x plus 4. Perfect. I'm just writing you out right now to show you where it comes from. Okay, now, this is going to be like 2 steps. You're going to take square root, just like that very first problem we did today. Do not FOIL, because that'll just give you back what you have above here. Square root and squared cancel each other out, so I get x plus 4. I put that square root in there, so I got to put a plus or minus. What's your square root of 36? 6. Okay, now all I'm going to do, I'm going to move this 4 real quick. And I'm going to have negative 4 plus or minus 6. Now, since that was a perfect square, we can actually combine here. Negative 4 plus 6 is 2, and negative 4 minus 6 is negative 10. So this has 2 nice answers. And we're going to finish after we... Okay, now, this is probably the worst question on the entire thing is, all right, we got to do 3 more examples real quick. Okay, I'm going to do the same kind of a setup. You want the term with the x squared and the plain x on the same side. They're already set up this way for you on the homework too. And I'm just going to complete the square on the left side so we can write those 2 factors together squared. So to do that, if you remember before lunch, this one's going to be a little tricky because the b value is an odd number. So I'm going to take the b value, which is negative 9 here, divide by 2 squared. Now, on the last question, right, I could actually divide that because my b value was even. You cannot do that here. So all I'm going to do, we're just going to square the top and the bottom. You want to leave this like a fraction, and I will show you why in a second. But if I square negative 9, that becomes positive 81. If I square the 2, that becomes 4. So what I'm going to add to both sides is 81 over 4. And leave that like a fraction. I'm going to explain that as we go through this problem here real quick. Okay, now, this is the tricky part. But if you remember what I promised you, whatever you squared, like we weren't able to divide that there, but I was squaring that. Whatever you square, that is what goes in the little factor with the x. So this would be x minus 9 over 2 squared. Okay, now, if anybody needs help with this on their calculator, I will show you how to do that. But I want to leave this like a fraction. So every scientific calculator, I know I've got a graphing calculator up here, but any scientific calculator should be able to convert this to a fraction for you. So I'm going to add 81 over 4. Okay, now, on the graphing calculator, if you guys are using one of these, there's a button, the fourth button down here says math on it. If you hit math, enter, enter, it'll convert that to a fraction for you. If you have a scientific calculator, I'll come look at your calculator if you don't know how to do it, but I want to leave that like a fraction, and I'm going to explain why in this very next step. This will always be over 4. Anytime you're completing the square, if you've got, and you're going through the process of doing that, that will always be over 4. And so, when I go through and take my square root here, and again, I know this looks tricky because of the fraction, but leave it as a fraction. So I have this x minus 9 over 2. Now, plus minus, because I put the square root in there, right? I'm going to just do the top and bottom separate. So, square root of 5, we can't simplify that. But square root of 4, anybody know square root of 4? 2. Okay, now, and this is how this works when you do this completing the square. I'm going to move this 9 over 2 to the other side, and this will be over 2, okay? And you'll see they have a common denominator. So that's why I wanted you guys to leave it as a fraction, because you can actually put these together. So I'm going to add that 9 over 2. So we would have 9 over 2 plus or minus square root of 5 over 2. Now, you can put these together, like the whole thing would be over 2. The top of it would just be 9 plus or minus that square root 5. And I know you guys probably haven't done this in a long time, but we'll do this in this unit, work on the quadratic formula. But a lot of the times the answer would end up looking something like that. But that's why I want you to leave it as a fraction, because you will actually be able to combine those, because they should automatically have a common denominator. Okay, now, obviously, these two answers, these were just nice numbers. This is radical answer, right? It's got a square root in it, but those are actually real numbers. The two at the bottom of the page we're going to do here real quick, same process, but these are going to have imaginary answers at the bottom. Okay, so first thing I would tell you to do, make sure your x squared term and your plain x term are on the same side. These should all be set up that way for you, so you don't have to move anything around. This is already just set up. But I'm going to leave myself a space to complete the square. So I'm trying to get that perfect square trinomial so my two factors can be the same, so I can write it as whatever squared. For this one, my b value is 12. I'm going to divide that by 2 and square it. So that's going to be 6 squared, which means the number I'm going to add to both sides is 36 to keep my equation balanced. If I add it to one side, I got to add it to the other. And I promise, whatever you square should be in the little factor with the x. So multiply to get 36, add to get 12, 6 and 6. So I can just write this as x plus 6 squared. Now, what's going to be different on this question is I'm going to end up taking the square root of a negative number. So see if you remember from our last unit. Negative 40 plus 36 is negative 4. So I'm still going to take a little square root here. And we still introduce the square root into the problem. So square root and squared cancel each other out on the left side. So just drop those parentheses. Still got to put the plus and minus. What would you tell me the square root of negative 4 is? 2i. Perfect. Okay, now this is actually easier than the previous two questions because we won't actually do anything else except move that 6 to the other side. So I'm just going to subtract 6, but you can't actually do the plus or minus 2i. So just write that negative 6 right after the equal sign and just kind of scooch over the plus or minus 2i. And then I can't go any farther because the I is imaginary. The 6 is just a real number, so you just leave the answer in that format. It's two answers. It's negative 6 plus 2i and negative 6 minus 2i, but I can't do anything more in terms of combining like terms because we can't add real and imaginary numbers together. So that's all I have to do. Okay, now the very last problem is probably the one with the most work, and it's because we're going to have to break down a square root in a second here. But I've got x squared minus 4x plus, I'm going to leave a space to complete the square. The other side has your plain number, and then I'm going to also put plus that little space to complete the square. So when we find this number, we're going to add it to both sides to keep our equation balanced. All right, so the b value here is -4. We're going to divide that by 2 and square that. That is -2 squared. If you square a negative number, it becomes positive. So I am going to add -2 times -2 is 4. I'm going to add 4. On the left side, it makes a perfect square trinomial. On the right side, we have to do that just to keep our equation balanced. I'm adding 4 to both sides. I swear to you, if you did this correctly, whatever you square, that's going to be what's in the little parentheses with the x. So multiply to get +4, add to get -4, x minus 2 times x minus 2, or just x minus 2 squared. So this is -2. This looks like a -2. Okay, -49 plus 4 is -45. So the last question, I just had a perfect square in imaginary land. 45 is not a perfect square. So this is like the worst possible thing you'd have to do is break down a square root like we were doing in our last unit. So square root and squared cancel each other out. If this were me, you know I like to find the biggest perfect square, but if you want to do a factor tree, you could do a factor tree. Just remember, if it's a negative number, you got to pull an I out in front of the radical. If it's me, I'm going to go, okay, the biggest perfect square that'll divide into 45 is 9. And I've got those perfect squares. Those are still up on the board for you. So I would rewrite that real quick as 9 times 5. Has to be a product. And then the square root, I just attach the negative to the perfect square so that way I don't forget to take the I out. Square root of -9 would be coming out as a 3i. So we'd have this x minus 2 plus or minus 3i radical 5. And then this is similar to the last question. I just need to move the -2 away from the x, so I'm going to add that to both sides. And so just put it right after the equal sign, 2 plus or minus. And then you can't actually do anything more because I can't add 2 to that imaginary number 3i radical 5. It's just going to be in that format. And a lot of the questions on the homework are like this, where it's just going to be like a number and then plus or minus. It might have a radical or it might have an imaginary number. Is anybody having a question?